There is only one example in 6.4, and this relies on doing a small experiment. And we hopefully will do this in class, but uh, if we don't for whatever reason, then hopefully this video will explain what happens if you did. So with an unbiased, again it's a die, uh, with an unbiased die, you roll it 240 times. That's quite a lot. And we're assuming it's six-sided as well. So six-sided. And if you roll it 240 times, it says that we have to calculate the number of times, not the probability, you would expect to obtain each of the possible scores. So what are the possible scores of rolling an unbiased die? You get a 1, you get a 2, you get a 3, or a 4, or a 5, or a 6. Now you don't have to write them out like this. You could just write them as 1, 2, 3, 4, 5, and 6. But you know, it's just nice to have them written in this way as well. So what's the probability if it's unbiased? Unbiased means it's fair, right? So you're going to have equal probability of getting each of these. So if you roll it 240 times and each one of these is a equally likely probability, then you'd expect, and remember this is a key word here, this is what you'd expect to happen, you'd expect for each one of these to be a sixth of 240. So a sixth of 240, if you work that out, that should be 40. So you'd expect each one of these to be 40 times. Now, the way that I've written this, it doesn't really make any sense. I've just written random numbers around here that don't actually mean anything. So I better label this so it's a bit clearer. So what do these 40s represent? This is the number of I guess number of rolls you'd expect. And the top one here is the number on the die. So that's the number on the die. Now it makes sense. Now the table is good. Okay, so it says calculate the number of times you'd expect to obtain each of the possible scores. Well, I guess I could just write the answer as 40 because they're all the same. Right, what about for part B? It says now roll the dice. Well, it should be die because you're only rolling one. Now roll the die 240 times and collect the experimental results. So if you did this, you would have to probably do it in a tally. So if you had the number on the die and probably better to have it going down the page, I think. 1, 2, 3, 4, 5, and 6. I hope this is still on the screen. And on this side, you would do a tally. Now, the reason you would do a tally is because when you roll it, you get, let's say, a 2, you put a mark. And then you roll it again, you get a 4. And then you roll it again, you get another 4. And then you roll it again, you get another 2. And so on. So you could end up by getting a big tally chart here. And after you've got all the tallies all written down, you want to write the frequencies as numbers. So, for example, you could have 44 in total here, you could have 42, and so on. But notice if you roll it 240 times, all of this would have to add up to 240. So you need to just check that before you move on. It's asking then for you to present it in a bar chart, and that would probably best be done on graph paper. But a small sketch here should show you roughly what it would look like. If on this axis you had frequency, and on the bottom axis you'd have the different score, so this would be a 1, 2, 3, and so on. And you'd expect them all to have roughly the same height, but by doing it experimentally, you'll see that they're going to be probably different. If it was a bias die, and let's say the likelihood of getting a 6 was much higher, the bar chart would look like this. And this is what you get by doing it experimentally. So if you rolled it, say, 240 billion times, then the frequencies would probably be much flatter. probably much more similar. And then if you compare the theoretical and experimental results, you'll see by doing it only 240 times that they won't be exactly as you'd expect. But if you did it many more times, then it would be much more about what you expect to happen.